Michael Acree, welcome back.
Well, thank you. It's good to be here.
So it's great for the audience. I certainly would urge people interested in this topic to go and back and listen to our first episode, where we went over your fantastic new book, The Myth of Statistical Inference, and really surveyed it. In a span of an hour or a little bit over an hour. It certainly doesn't do justice to the topic, but at least it gave a sense of your main thesis in the book, which is that statistical inference is a myth because it tries to wed two notions, two concepts of probability that really can't be wedded. One concept is probability as a ratio of frequency of events, in a given set of events in a long series of repeating events. And the other one is the probability in the sense of degree of belief. How strongly should I believe that X will happen, or that sort of thing, or that, you know, such and such is guilty, or whatnot. And you make a very, very cohesive and coherent and persuasive uh, case that the development of statistical inference, the development of the whole field of statistics, maybe not entirely the whole field, maybe I'll ask you to clarify or qualify this, is essentially uh, uh, is based on the thought that these two concepts of probability can be actually wedded, but they fail. They fail, but despite that failure, we continue to use statistical inference as if there was nothing to it, and that's where we are. So today, I'd like to take this more concretely and see how in our day-to-day lives and practice, and when I open the pages of the New England Journal of Medicine, how is that myth sort of influencing the conclusions that I'm reaching, that sort of thing. But are you? Is that a fair enough rendition of what we talked about last week and your general thesis? And maybe I said maybe you may want to qualify. Maybe descriptive statistics are salvageable, right? Or
Right, right. Yeah. It's
okay,
wonderful to hear your summaries because you're always so right on the money.
okay, thanks, thanks. So descriptive statistics are okay, but when we either conduct an experiment or conduct an observational study and then apply some form of statistical procedure to help us draw a conclusion, if our conclusion is based on that statistical procedure, then we have a problem. Is that fair? You're
That's
nodding, but there
fair.
are people who are listening on audio podcasts. They may not see
Okay,
you nodding, so okay.
okay, okay. I'll try
All
to
right.
remember.
Okay. So let's say I read the Lancet and I read about a cluster randomized control trial in Bangladesh about various masking, where some villages, they mask them with cloth masks during the pandemic. Other villages, they mask them with surgical masks. Other villages, they keep that as a control group and whatnot. And they collect data. They see how many people get infected at the end of the observation period. And we're not going to get into what specific statistical procedure they've used. But let's say they use a statistical procedure. Um, and from that, we get a, a result, a difference between these groups. And the procedure tells us that it's statistically significant, and therefore we should believe it, or we should draw some conclusions.
Right.
So where is the mistake there, or what is it that we shouldn't be doing?
Okay. Well, there's a good clarification along the way that you put in there. Um, when I say statistical inference is a myth, I mean it in the same sense that I would say that unicorns are a myth. There is no such thing.
Mhm.
And likewise, there's no such thing as statistical inference. There's no category of inference that could be called statistical. But that doesn't mean that everything we do, everything that anybody does with statistics is invalid. We're talking about one specific set of procedures, which is widely used. As you say, descriptive statistics are a good example. There isn't anything objectionable about them. They're problematic in psychology because of the measurement problems in psychology. We don't have good psychological measurements of anything. But in medicine, it's a little different. Measurement isn't such a problem in medicine. As to the consequences, it's kind of a funny question for me. I say somewhere in the book that I'm 100% in or intuitive on these Myers-Briggs type tests. I have just zero interest in anything practical or concrete. So when I first started lecturing on the topic of my book in 1987, the first question people asked me was, well, how do we analyze our data then? And that's a question that wouldn't have occurred to me in a million years. So it's good for me to get some exposure to other people and see what they're interested in. And likewise, your question of where we go concretely wrong is one I didn't address explicitly enough in the book. So it's good to have the chance to talk about that. It's also a kind of a funny question to ask how the world would be different if people rejected a certain belief. So if, I don't know anybody who believes in unicorns, but if the world were to give up the belief in the miracle of the Eucharist, for example, then what would be the consequences? They may not be easy to say. In this case, the consequences are actually concrete and serious and widespread if we know how to recognize them. But there's a trick to recognizing them. I might observe first that when people do a significance test, which is one of the main instrument of statistical inference, this is especially prevalent in psychology, but I think it's also true in medicine. Despite years of statisticians screaming to them that it isn't true, it isn't the way to do it, they still believe that the p-value is the probability of the null hypothesis being
true,
false.
Right? Being false, right? Okay.
Okay.
Right.
So a former colleague of mine who's a very distinguished psychologist, now retired, written a couple of good books, and he has a glossary explaining concepts like statistical inference for readers who may not be up on it. He goes ahead and uses exactly the words that I do in my book when I say this is what you shouldn't say. He says a 0.05 p-value means there's a 95% probability the null hypothesis is true, or the alternative hypothesis is true, the research hypothesis is true, which is what we want. So the first and immediate consequence of people's reliance on statistical inference that they believe their hypotheses, the ones that come out significant, are almost certainly true, and that's not true.
Right.
But of course, they would never have any way of knowing that. We don't have any way of knowing whether our hypotheses are true or not.
Right.
And we protect ourselves from discovering that by always taking only one sample to test a given hypothesis. We only do an experiment once. So we can't see the variability from sample to sample, which we would if we routinely tested a hypothesis 20 times and then a meta-analysis on our own results or something. Then we could see the variability. Once in a while they would cluster, but usually they'd be spread out all over the place and our research results wouldn't be so convincing. So that's the first error we make, is that we're much more inclined to believe our research results than we should be. And that's where the replication crisis comes in, that you mentioned, because some people have recently undertaken to try to estimate that quantitatively and have shown that our research results are not replicable. Brian Nosek is a good example. You've had him on this program a couple of times.
Sure, I put a link in the show notes. Yeah.
You got a team of 300 or 400 people together, and they repeated 100 experiments from several top journals. And they were able to get replications in the sense of also getting significant results in 39 out of the 100, which pretty much means our research, all of it, is less than worthless. We're relying on research results which are known to be unreliable.
Mm-hmm. That's provided we apply that understanding of what the p-value means, which is incorrect, right? Meaning that it gives us a certain it gives the probability of the null hypothesis being false, right?
Right.
When in fact, when we repeat those tests multiple times, all we're seeing is really the natural variability in a sampling procedure, if you will, right? I mean, with that.
That's exactly right.
Okay.
Exactly right.
Okay.
We're doing estimation, and we're constructing confidence intervals and so on. The uncertainty in our estimates is the uncertainty in our sampling procedure rather than the uncertainty in the population mean. Mm-hmm. Mm-hmm. Population mean just sitting there not doing anything. And it's our sampling procedure, our estimation procedure that is uncertain. But we lose sight of that, of what we're doing.
Right. But if the consumers of medical journals and medical news and psychological news were careful and knew not to interpret the p-value in relationship to the null hypothesis, but interpreted it correctly the way the theory would want us to interpret it, meaning that it's the probability of the data being true given the hypothesis, right?
Right.
We talked about that in a little more detail in our very first podcast with you a couple of years ago that I will link on the show notes as well. If we did that, does that solve the problem of does that make the problem of statistical inference go away, or is it still there?
No, I think it's still there.
Right. Okay.
But we don't know what to think of the hypothesis. We've just got the probability of the data. We know that that's highly variable, can vary all over the place. And so in terms of whether to believe research results or not, we can do things like critique the design of the experiment and so on, other features. But in terms of what the statistics are telling us, yeah, it doesn't help.
So, and is it because the theory that would allow us? Sorry, there's a little siren going on here. Let me mute myself for a second. Okay, so the theory itself has, I mean, I think as you mentioned, that makes assumptions, right? I mean, the frequentist theory of probability, that understanding of probability, makes certain assumptions that are not unverifiable about what the sample tells us about the larger the population mean and that sort of thing, right? I mean, it makes some assumptions.
Right.
Is that why this even at that level, even if we understand what the p-value means correctly, that we still have a problem of statistical inference?
There's a lot that goes into a p-value properly understood. And taking all that stuff into account, it's just very difficult to know what to make of a p-value. Yeah.
Okay.
So what that says about the truth of the hypothesis.
Right. Okay. And that we don't have to get into it, but that applies also to the Bayesian theory. So the Bayesian theory doesn't, for the reason that we've addressed on the last episode, is not really doesn't solve the problem. I mean, it doesn't give us any ground to believe, to infer based on the probabilities, infer anything else.
It's perfect that you brought up Bayesianism in this context, because Bayesianism, on the one hand, does allow us to say there's a 95% probability of our research hypothesis being true. And so Bayesians do feel justified in believing a hypothesis, but they have in common with the frequentist statistics the core of the sampling practice. So Bayesian statistics can't do anything about the sampling variability of the samples. So that's just as much a problem for them as for the frequentist statisticians. Mm-hmm. Mm-hmm. So the replicability crisis really comes at us either way. It's a sampling issue.
Right. So, Mike, you've been doing this professionally for a long time, assisting researchers analyze their data, and this thesis of yours that is now materialized in a wonderful book has been on your mind for a long time. We talked about it before. I mean, you had an inkling that was the case during when you wrote your PhD dissertation, and the rest of your nighttime work, or your second job writing this book, has only confirmed that intuition or that realization. So what were you thinking, or what was in your mind when you were advising other researchers? I mean, what kind of conversations? Did you keep quiet? Did you just, were you going through the motions of, there's obviously an entire, and that's been discussed, I think most of the audience would know about it, that it's journals, publications, grants, all of this depends on the myth of the statistical inference, right? Because you want to show, everybody wants to show that they have significant results
right.
That are justified by the p-value. Were you ever in a situation where you were advising somebody who was genuinely trying to understand what their data was meant, to show them that the statistics were not going to be the answer one way or the other?
Yeah, actually, I think I have worked with a few researchers who actually were interested in understanding what their data meant. And my focus was on helping them understand the math of it, as you will. If they made statements in the write-up of the research that were unsupported by the theory, if they said, hence the probability of the null hypothesis being true is only blah, blah, blah. Yeah, I corrected that sort of statement that might go into writing. I didn't undertake to re-educate everybody completely about the statistics that they might have learned. Yeah, a lot of the statistics I was involved in doing were very complicated, things that are difficult even for a statistician to understand. And so quite a lot of the explanatory work went into that.
Right. So now I think what we don't want to say, or maybe, I don't know, but my view is that we're not necessarily, it doesn't mean that we have to be nihilistic about research data. Right. We still infer things from experiments that are being conducted. Or do we?
Well, yeah, I want to respond to that question as well, because it may not be obvious where to go from here. We could, in one sense, just repeat all of our experiments 20 times and do a meta-analysis of our own results, so on. That would clarify our misunderstanding, so we place less confidence in our results. Mm-hmm. But nobody's going to put that much work into verifying something that they don't want to know, namely that their research results are highly variable. I think that the key problem is that for a century in psychology and a half a century in medicine, statistical inference has very largely reshape the research questions that we asked in the first place.
Mm-hmm.
I don't think most doctors or psychologists had in mind when they started out that they wanted to understand populations. They might want to understand psychological or medical processes or mechanisms or something like that, but not population data. As you said in the beginning, statistics in that sense still has its place. I mean, epidemiology is a statistical science and a legitimate one, but we've transformed all of our research questions into epidemiological questions, and we set them up to give us epidemiological answers. You take a research problem to a statistician, the first thing he does is write down a statistical model based on populations, but yeah, that's not what we're asking about. We're asking about, what's the effect of a drug on cholesterol, and it's not asking about the population effect, which isn't a real effect in the world.
Right. I mean, well, we do to some extent. I mean, and I'm not sure if it's now under the influence of statistical inference, or if on the other hand it's statistical inference that are helping us do this. But we, I mean, right now we're like the clinical guidelines about how to practice medicine. They ask clinicians to start putting their patients in certain population categories. So diabetics, people with diabetes are form one category, or people who have coronary disease that is asymptomatic, you put them in one category, as opposed to coronary disease that was symptomatic in the past. That's a different category. So you categorize them, and then you analyze them as populations. Now, one hope, I suppose, is that the more you categorize and the more data you have, that you can categorize in more granular ways, so that you can have one patient that is diabetic with coronary disease that was symptomatic and all these things, doesn't have hypertension and whatnot. You can do these things. And if you had enough sample, large enough populations of 40 to 50-year-old women with diabetes, without hypertension, with coronary disease, that is asymptomatic and whatnot. But quickly, the amount of studies and data that you would need to make statements, sort of population statements, would be sort of enormous.
That's a very good formulation. I think that's been the dream since Bernoulli and Gavaret and so on in the 18th, 19th centuries, to have these gigantic population bases of statistics, which we won't ever have. They change much too fast to keep track of. I was thinking of another example that maybe you could help me with in terms of pressing medical issues these days. I would really like to see something about which kinds of people are most susceptible to bad effects from COVID vaccinations, for example.
Mm-hmm.
Heard that 17,000 people have died this year in the US. And a lot of them were myocarditis or Guillain-Barré syndrome or various other things. But I haven't heard anything about which kinds of people are more susceptible to which kinds of symptoms than others. We know in general for COVID that being fat and low in vitamin D puts you in a high-risk group. But we don't know much about susceptibility to the vaccine for obvious reasons. The reasons for not doing that research are obviously political rather than scientific, but that's a kind of question that I would think of as more bench science than survey science.
Right. No, it's true, but you're still you're still trying to answer a question to some extent about a population. I mean, who is the susceptibility that would describe sort of a group of people. I mean, I think if medicine is going to be at least have a scientific, so it's not a science in itself, because medicine is not the goal of medicine is not to produce knowledge. The goal of medicine is to help individual people.
Right.
But it wants to help individual people. So you know that Aristotle in the first chapter of the Metaphysics talks about precisely this point. He says that the physician is not he makes a distinction between the physician who can cure like somebody who knows a recipe but can't explain why. He says, okay, you know that you just add a little salt and a little herb and a little this, but you really don't have any science,
Right.
right?
Right.
Whereas the physician needs to understand, who's going to benefit from this treatment, sort of as a general class. So there's a need to be able to make a statement about a certain population or a class of individuals that will benefit from the treatment, or a class of individual, for whom it makes sense to affix this diagnostic label or whatever. So there's a need to generalize. You can't just say, well, Mike Acree, you're irreproducible. There's only one Mike Acree in the world. That's a true statement. There's only one you, and therefore I can't know anything about you because you're unrepeatable. And it's true that you're unrepeatable, but at the same time, there has to be something about you, about your habits, how tall you are, how heavy you are, what you do, what your blood tests show, that can be sort of generalized. I can infer from an experience that I've had with other patients that are similar to you, to be able to apply a treatment to you. And so the question is that, I mean, it seems to me that if we want to, so I agree that there's this work of generalization that has to be made, but the moment you want to quantify it, sort of very precisely, then it breaks down. I mean, I think there's something that breaks down in insisting that your inference that you're going to make has to be driven by the statistics. When in fact, I think there's a work of inference that we have an ability to infer knowledge that is true from our experience that is not quantifiable, but is nevertheless
yes.
true. Okay, so
Yes.
it's not quantifiable, but it's never true. Which is why I think that these studies, these randomized controlled trials, I mean, they're helpful, but I think they'd be equally helpful if they left out all the statistical analysis. I mean, apart from this, right? I mean, they could have the descriptive statistics, but they can leave out the procedure of inference to calculate a p-value. Just put what the results are, how often certain outcomes were in one group, how often they were in another group, and let the reader or the observer just draw some inferences on his or her own. How do you react to that? I mean, I'll tell you why I think that's not accepted, but what's your reaction to that?
Well, I love your saying it. I think that's a perfect formulation. I'm thinking that if we retained randomized controlled trials without the statistics, as you suggested, we'd pretty soon find that we didn't necessarily need the huge numbers that we do in randomized control for
Very good point.
power. If we were starting from, as I said, bench science, so maybe just looking at half a dozen cases would give us some strong hypothesis about what the present or absent effects were for who got sick and who didn't. And then they could be tested on some more. And we wouldn't have to do 1,000 cases to verify it. We might feel pretty well assured with
right.
10 or 11.
Yeah, that's right. Because the only reason we do 1,000 cases is to get to the p-value that shows significance.
Right.
Whereas with a fewer cases, now the pushback is going to be that look, with only a few cases, you can, if you repeated it, then you might have a different answer, and whatnot, and so that's true, and I think so that that's what's very difficult to convince people of, is that I think you can make correct and incorrect inferences on the basis of small samples. So I mean, you can obviously make incorrect inferences on the basis of any sample, whether large or small, but I think you can make correct inferences on the basis of small samples. But it's impossible to prove that I, Michel Akkad, am a wise guy, and so it's impossible to prove mathematically, but you can demonstrate it socially. You can demonstrate it socially by having people who seem to be wise and who seem to make reasonable decisions um, in how they analyze data. They can come up with arguments, and then they will draw on a variety of sources of arguments. As you mentioned, bench science, for example, might be one. There may be other arguments to support a certain interpretation of the data of a small sample in order to do something. But that's unacceptable in a world that wants to remove these sort of fuzzy, subjective qualifications. Somebody being wise. Well, what does that mean that they're wise? You know, we need to have proof. So we need to quantify everything in order to prove it mathematically and to standardize it and to remove any kind of variation in practice patterns so that we all practice in the same way.
Well, I don't think our knowledge claims have to rest on a general social perception of ourselves as especially wise or brilliant. If we think about another example I've heard about in medicine, the discovery of blood groups, which was a century ago or something, I don't really know. And you mentioned that, this discovery may be overturned at some future point, and indeed it was in that case. They found blood that had the same type that coagulated, and it wasn't supposed to. So then they knew that there must be another factor that they hadn't discovered, that they hadn't taken account of. And that's what they looked for, and that's what they found. And I don't think the acceptance of that rested on what wise men they were, that science sort of spoke for itself.
Right. But the first, I mean, I'm not sure. An example I have in mind is a doctor discovering or inferring from his experience that, let's say, a certain treatment is beneficial, without the benefit of a clinical trial with a p-value
Right,
proving it to be the case.
right.
Now, for that doctor to make the case for it to be socially acceptable, I mean, how can a doctor say, so I don't know if you've heard the term eminence-based medicine.
Eminence,
right. So it's the people
No,
who are vaunting evidence-based medicine, so evidence-based medicine is obviously relies on these statistical procedures, right, on the test of statistical significance. They were sort of discrediting the old way of having a chief of department saying, in my experience, we should do X, okay, because I'm wise and whatnot. So, I mean, it's true that you can have a lot of unwise people in position of power, influencing medical students and whatnot, and in ways that are not good. But at the same time, it doesn't invalidate the possibility of wisdom, the possibility of having a person who's actually wise and can actually make the correct inference without the need for the clinical trial and the statistical procedure. And that the statistical procedure introduces distortions, and first of all, it's it has all the problems that you mentioned, but it has, as you said, it forces, in a way, it forces a reduction, so to pay attention to only certain variables, right? Because whenever you make these experiments and draw, you mentioned that in your book. I think we may have talked about it last time. That there's a forced attention to a certain. So it's not, is the patient healthier at the end of the experiment? Is what are the outcomes, right? So you have to narrow down your attention and your investigation to very specific traits. I think it relates to the. I don't know if we mentioned it in our conversation last time, but we talked about it with Laplace's theory of frequency when he experience with ducks going down
Oh,
the river and
yes.
each one of them being black, right? So it's the statistical procedure forces one um, uh, um, to narrow down not to narrow down. What's the word? It's not to narrow down. It's to identify a few uh, trait traits in the person of interest at the exclusion of others, and because that's what you're going to count, right? You're going to count how often this event happens, or whether this and that, in the person, as opposed to having a more holistic view of the person. And
Yes.
so um, so my point is that so that's not good. I mean, that's not good for medicine if that's all you pay attention to, right? If
That's
we
right.
all were driven by, if we took this at to its ultimate conclusion, then we would we would have algorithm, we would have clinical trials that are well conducted, maybe repeated once or twice, dictate how medicine should be practiced, and we should try to fit all our patients in a category that is suitable for analysis under these evidence-based guidelines, and then treat them mechanically. We'd have robots just give them their prescriptions or perform the surgeries. And nobody really wants that. Nobody really believes that. But that would be the sort of the natural
Right.
conclusion that one would have to draw from that train of thought. So we obviously all believe that we have ways of making good decisions, whether it's in psychology or in medicine, that take into account a different, or that acquires knowledge in a different way, or acquires a different kind of knowledge, or something else that is not
Well,
quantifiable.
one of the things that's crucial to keep in mind is that we're as biological beings, we're organically organized. So that goes against the mechanism that's been the prevailing philosophy for centuries, where we're just aggregates of characteristics that can be added or subtracted. That's what we do in our regressions and everything else. But
Right.
to do effective medicine, I think we have to take into account our knowledge of how things are related. All different characteristics are related. And you can't just add and subtract at will.
That, that's exactly right. You're absolutely right. And it's unquantifiable. There's no way to apply, um, to subject that understanding of the different relationships between the different parts of the body, or of the human person in general, in a way
Right,
that lends itself to statistical analysis.
right, right, right.
Yeah. And and then and then the other thing also about the criticism of eminence-based medicine, of being the pontificator saying, in my experience, this treatment works, and then somebody else repeats that thing, and then it falls apart. Well, the one problem here, I think is a legitimate problem, is that you never repeat the same thing. At least I think I mentioned that before. I mean, all these are historical events, right? They, if I, even if you repeat a clinical trial under
That's true.
the conditions are always going to be different. So is it
Right,
is it actually
right,
the same clinical trial, right? You can repeat it 20 times, you can apply the same protocols, but at the end of the day, it's going to be different people, right?
right,
They're going to be
right,
different
right.
people. Perhaps something in the air has changed, or the magnetic field of the Earth has changed to the point that
That's right.
your
That's right.
things are thrown off, and so your numbers are never going to be exactly the same. So you're still going to have to decide whether the difference between these 20 different experiments, to what extent they are the same, or to what extent they are different, and what to
Hmm,
consider
hmm.
a difference significant and not significant. So it wouldn't even help to repeat clinical trials 20 times.
That's
Uh,
right. That's right.
right.
Yeah,
Um, there has to be a judgment that is made that is outside the realm of quantification. And that doesn't mean, for most people, it means that it's a completely subjective judgment. But I don't think so. I think it's not a subjective judgment, and there can be good judgments and bad judgments. And
absolutely.
we somehow we recognize them, or maybe we don't, and maybe that's the tragedy of the human condition. that, but I think we need to defend the possibility of inferring, right? Because it's a process of inference, of inferring knowledge outside of statistics, outside of
That's right.
these quantifications.
That's right. I was going to add in there that we need a distinction between subjective and merely subjective.
Right, right, correct, correct. That's exactly right. They're subjective in the sense that it's a judgment, but it's not merely subjective because it's not whimsical. It's a judgment that is based on inferring something from our experience, which means something real. And in fact, and we should cultivate. And the problem is that we should cultivate. Again, I mean, I'm channeling Aristotle here, but this is cultivated. You can cultivate your good subjective judgments, your good
Yes,
sense with experience, with
yes,
wisdom, with good habits, good work habits, and so forth. You can cultivate it. Whereas the statistical procedure, so long as it is seen as a substitute or even a better way of inferring than the judgment, atrophies your ability
yes,
to judge properly.
yes, yes. There you go.
Yeah. So good.
Yeah.
Can we knock this horse, further down, and can we kick this horse while it is down? Is there any more to say
Right. Or
against
somebody going to call the Society for the Prevention of
right?
Horses.
But this is important, and much of what we're talking about, I think you address in the early chapters of your book, the first two chapters, where you give the context from which statistical inference and the desire for um, these quantification and the statistics has emerged. We're not going to go into it, but I just want to mention, at least to the audience, that you give a very broad, sweeping, and very interesting historical perspective on all these ideas that are very important for certainly for physicians, but I think for all of us to be aware of. That there's a way of thinking through this, and we are certainly influenced today by our historical conditions, and it doesn't have to be that way. There are different ways of thinking about the world that can
That's,
inform us. Yeah, go ahead.
that's very good to hear your support for that chapter two. I get the impression from a lot of friends, I don't think they see it as that relevant or important, but it really seemed so to me when I was working on it. Yeah, how our whole present way of thinking about things came about. And
Right, right. No, it's extremely important because the the uh, the emergence of statistics in the 17th century was facilitated by a certain context that is philosophical, right? I mean, it was a change in the philosophical context
there really
without
was.
which this. Now, of course, most people will say, "Well, look, I mean, who wants to go back to the stone? I mean, you would be characterized as a Luddite if you want to go back to certain ideas that were present in the past.
Right.
Um, but so be it. I mean, I mean, it's true. It's true that this way of this modern way of looking at things that has focused our attention on the narrow characteristics that can be quantified in order to make certain inferences, um, perhaps has allowed us to predict things in a better way, and therefore to develop technologies, right? Certain technologies that would not have been possible without that frame of mind.
Hmm.
I mean, I'm willing to grant that. I'm willing to grant that that it's that progress comes with at least the material progress of the last 300 years um, depends on a sort of on this attention to the quantification and but at the same time, I mean, I don't, so are we that much happier for it? That's a philosophical question, right?
Yeah. Yeah.
Um, so that remains to be seen. Um, I don't know. Sorry, I'm sort of waxing philosophical here, and
Fine by me.
right. Well, Mike, that was delightful. Those two episodes are very important for people who want to think about these questions more deeply. your book is very important. I want everybody to go on Amazon.com or wherever they buy books and order a copy and immerse themselves and read it carefully, um, because we all need we all find ourselves these days in this time of crisis. It's a crisis at so many levels. It's not everybody realizes that it's not just a pandemic, right? That
Uh-huh.
that we
Uh-huh.
need new ideas, new ways of thinking about the world, about how we live together in community and all that. And I think your book makes a contribution to that conversation.
Thank you so much. I sure appreciate the recognition. Yeah.
Thank you,
And this
Mike.
has been a great conversation too. I felt like you really were contributing a substantive uh, amount to the discussion. Yeah.
Thank you very much.